Hi, I'm Terry Monville, technical advisor at Goujon Brothers. The other day I got a phone call from a friend about his engine hatch that was leaking a nasty brown water out of it on his 31-foot powerboat. So after taking a look, we determined that the balsa core had rotted out, and we decided to do a repair on it. Using a moisture meter, we scan the whole hatch and write down what the reading is in different areas. This will give us an indication of how bad the core is rotted away or how wet it is, determining how far we have to do the repair. I cut back where I knew I was only cutting through the inner layer of fiberglass and not all the way through the core, and cutting all the way through the hatch, the outer fiberglass, and doing damage to the cosmetics. I'm using a 4.5-inch skill saw to do this. I can set the depth shallow, and that way it makes it easy, and it's a good tool for the job. Unfortunately, we were not able to remove the entire piece of fiberglass in one section, so we cut it into smaller pieces to make it easier to remove. There's no real equipment designed for doing this, so I mean, just use your typical shop equipment and do what you can. As we cut this hatch apart, we found a couple of interesting things. On 1/3 of it, it was 2 layers of 3/4-inch balsa, but over on the side closest to the hinges or the back of the boat, we found that there was balsa and then 3/4-inch plywood underneath it. Then we go back with the moisture meter and check other areas to see how it compared. As you can see, you get much higher readings after the laminate is off, and you can see the dark spots of the rotted out core. You can scrape a lot of that away. You can see that we cut it away here, got rid of all the easy to get away balsa, and you can see that the plywood has relief cuts in it from factory, and those actually worked as an irrigation system for the water that once it got in there, it was able to distribute the water throughout the whole deck. Again, using an air chisel this time instead of just a hand wood chisel from the shop was easier to get a lot of the core off. And then using an oscillating saw, now that I know what I'm working with, I can cut back further and remove more of the core and dry the wood out better that we're leaving. And we want to leave enough of a lip around the edge so that when we grind it off, that we can grind it 12-to-1 taper from the thickness of the fiberglass that we removed. That's what we're doing here, is grinding it back and prepping for the laminations. Installing new backing plates for the hinges. Again, this is where it leaked. So I'm sealing it up and sealing the relief channels with 610 adhesive to prevent water from coming in again and ruining the core. Also going to take some fiberglass and fiberglass around those hinge backing blocks. This way we'll be able to laminate right up to them, and it'll be a lot easier to do than trying to work around those little blocks fitting big sheets. We're going to vacuum bag the core in, so we're going to use thin layers of fiberglass to create backing plates to create an airtight seal. Here we'll use a little 105-206 with 406 filler in it to thicken it up and do a 2-step bonding, where we actually wet the surface out and then put a thickened epoxy on with the 406, and then again on the piece that we're installing, which happens to be fiberglass in this case. And that will keep a nice tight air seal for when we do the vacuum bagging. While those are carrying out, I'll start fitting my balsa core into place, tucking it up underneath because we scraped all the way back to the edge, and then putting in the big panels and the big areas, of course. You want to make sure to fill as many gaps as you can, cutting and fitting it, and then any gaps that are left over when installing it, we'll fill with the epoxy thickened with 406 as a bedding compound. Here we got the first layer down, and now we also have the second layer in, and we're getting ready prepping it. You'll notice black lines in areas. Those are for alignment, as one piece of balsa will not cover the whole thing. We cut and fit it, and then use little alignment marks so when we go to put it back in, we know where each piece goes. We're wetting out. We always do 2-stage bonding, which is where we apply mixed epoxy first, and then we'll follow up with a filler. We wet the back of the core out, and then we put down mixed epoxy with 406 in it as a bedding for the balsa to go into, or core, whichever one you end up using. Spread an entire area, and then we're going to put in the first section where there's only one, where it's 2 layers. We'll put the first layer in to bring it up even with the plywood. Now that we have that installed, we're wetting out the rest of the plywood and all the relief channels. We've decided that along the way that we're going to fill the relief channels with a mixture of epoxy and 410 microfiller. It's lightweight filler, but that will prevent water from being able to get into that area. And then on top of the plywood, we're putting another mixture of the 105, and we're using 209 hardener in this case to slow it down a little because it's a large job. And then we bed the core back into there. And any place we join different pieces of balsa, we actually use a little bit of the thickened epoxy with the 406 to, again, create a bedding to fill any gaps and joints in it. Also, once it's under vacuum, some of this epoxy will soak through the balsa on the cuts and reliefs to help prevent water from flowing and also creating water seal. Here we're going to put down some release fabric. This will prevent the breather fabric from sticking to the balsa as that epoxy soaks through it. The breather fabric is used to allow the air to flow evenly underneath the vacuum bag. We use vacuum sealant tape around the edge of the hatch to create an airtight seal between the vacuum bag and the hatch. We'll cut and fit it and put some pleats where needed to take up excess bag, but we want to make sure that there's no way for air to get into it. The advantage of the vacuum bagging core into place is not just the fact it will hold even pressure across the whole surface regardless of the shape of the surface, but it will also draw the excess resin up through the kerfs of the core. This preventing water from being able to migrate from one block to the next. In case there is another leak, it will contain the rot into one location. As we start to draw the vacuum down on it and the bag tightens up on the hatch, we make sure to fit it into corners and around the edges of the balsa so it doesn't create any bridging, which would create an air pocket that we don't want. We're only going to draw down 5 inches of mercury. 29.5 inches of mercury would be full vacuum, but 5 inches is more than enough as that generates 2.5 pounds per square inch of pressure between the bag and the hatch. It's equivalent to parking 2 Chevy Suburbans on top of it. Nice thing about vacuum bag on core is that it creates an even pressure regardless of the shape. If you're going up around the sides or on a curved surface, it's all equal. Remove the bag and the breather fabric and release film after the epoxy is cured out. And then just do a light sanding to take care of any lumps and bumps to smooth it out for the fiberglass. Around the edges, soak the surface of the balsa, some epoxy to prevent it from sucking out the epoxy out of the fabric when we start applying that. Again, part of the two-step bonding. Around the edges, we use a mixture of epoxy and 406 to create a fillet so that the fiberglass fabric will roll evenly and smoothly across the surface. Again, not creating any air gaps. The roll of fiberglass was not as wide as the part, so we did have to do it in a couple of pieces. And with that, we'll overlap the cut line about 1 inch, and we'll also alternate it from side to side so we don't create a weak spot or a large bump in any given area. We want to apply enough epoxy to saturate and remove all the white of the fiberglass, but we don't want to put on so much epoxy that we create a pool of it and float the fiberglass. Fiberglass should be tight layer to layer. Even though we're not going to vacuum bag it, we're going to use release film again. The nice thing about it is it removes mean blush and leaves a nice texture behind so that you can put on the next layer of fiberglass or your finish coat over top of it. Here we're installing a block of 3/4 plywood, which is used as a reinforcement for the hatch lift mechanism. The old one is just bonded to the surface of fiberglass. I'm going to go a little bit further than just bonding it on and lay a piece of fiberglass over top of it for extra support. Again, doing a two-step bonding, wetting out both surfaces, adding in a thickened epoxy with 406 filler in it, making sure it's in place, and then again going around the edge of the plywood with 406 filler and making a fillet for the fiberglass fabric to roll over the edges nicely. Ideally, you don't want to have air between the fiberglass that you're applying and the wood and fiberglass you're applying it to. Once again, release fabric, help with the mean blush removal, and have a surface prep for the next step. Here, cleaning up some rough edges so that it's nice and smooth and ready for gel coating. Go around the edges, get it all prepped, and vacuum it nice and clean. And I used a finish gel coat. Finishing gel coat has wax additive in it, and this way it will dry to a hard finish. Here we're installing the hardware for the engine hatch lift system. Oversizing the holes and filling them with epoxy prevents moisture from getting in and also makes a stronger bond. And I use cooking spray as a release agent so that if I ever need to remove them again, I'm able to. Doing the same system here on the leg supports, oversizing the fastener holes, filling them with a mixture of epoxy and 404 high density filler. And then on the inside the holes, we cut back the balsa about 1/4 inch and filled with 610 adhesive. 610 adhesive is nice for this project. It stays in place well and creates a great water seal. Again, on the hinges, doing the same process. Even though the hardware holes have been oversized and epoxied, I still use a bedding or a caulk on the screws and around the hardware to make sure that no water gets in underneath it. Even if it doesn't get in the screws, it still can do damage, particularly on this hatch. So I make sure it's well sealed.